This question is about electrostatic repulsion, and specifically electrostatic repulsion on closest approach of an alpha particle. So you can actually get to the answer of this one pretty quickly. If I just sketch it out. So we've got an alpha particle, we've got a path given here, we've got a point of interest that's called P, and then we are told there is a nucleus here. And it isn't on direct approach, it's coming in at an angle, and you've got this general setup. And then we're given some statements that we're asked to say are true or false. Just to be aware, at any point, if the alpha particle is here, then the repulsive force, the force acting on it, is a direct line from the nucleus. So at this point, although it continues in this path this way, actually the force on it, and it'll be a little bit stronger because it's closer, the force on it is in this direction at P, although its velocity is in this direction, and that is why it continues in its path this way. So we've got some statements we need to say. So the acceleration is 0 at P. Well, that doesn't make any sense because P is at the closest proximity to the nucleus, and P at that position, the alpha particle is positively charged, the nucleus is positively charged. You meant to know that from Rutherford's alpha scattering experiment. So the force at closest approach will be greatest. That doesn't make sense. It's the opposite. So and the acceleration is 0 at P. No, the acceleration is at a maximum at P because the force is at a maximum. Kinetic energy is greatest at P. Well, although there is some kinetic energy, actually the kinetic energy will be least at P because as it approaches the nucleus, work is being done, and the work that's being done against the force, although it's not moving in a direct line at this point, no work is being done. At this point, we are moving, we have a component of velocity and a component of the displacement is going in the opposite direction of the force. Not directly, but it is in the opposite direction to the force. So some work is being done. So as it gets closer to the nucleus, work is being done, and to do work, it must be converting kinetic energy into the electrostatic potential, the electric potential energy. So kinetic energy is being converted into electric potential energy. If it was a straight line going in, it would stop and then head back. Because it's going in at an angle, it doesn't stop, but it's got least kinetic energy here. It's got the least velocity there. So kinetic energy is actually at the least at P. Potential energy is the least at P. Well, actually, the potential energy is the most at P. So that doesn't apply. Potential energy is the most at P because it's the closest point, and they're both positive and it's repulsive. And then the speed being least at P is actually correct. So the speed is least at P. For the reasons I've explained, the speed will be the least at P because it is converting kinetic energy into electric potential energy.